When you type a comment and GitHub Copilot instantly generates 50 lines of perfect logic, it feels like actual magic. But behind that blinking cursor is a high-speed data pipeline, packing your local context into invisible snippets. Today, we are stripping back the curtain to see exactly how your code travels across the wire. Let's start with what most people get wrong. Code generation does not happen in 0 milliseconds. That blinking cursor is not just waiting. The moment you stop typing, your IDE is already working. It monitors your cursor position and file state, and the instant it detects a pause, it fires a background request. You never see this happen, but it never stops happening. Now here's where it gets interesting. Before anything leaves your machine, a process called context packing kicks in. Your local extension does not just grab the current line you are on. It scrapes your open tabs, reads your neighboring files, looks at your imports, your recent edits, your comments. It is building a situational snapshot of who you are as a developer in this exact moment. Then a ranking algorithm decides which parts of that context are valuable enough to fit inside the limited prompt window. Comments get prioritized. Library names get prioritized. The function you just wrote 5 minutes ago gets prioritized. Everything else gets left behind. What actually leaves your machine is a carefully structured data packet, not your raw code. A distilled, compressed, ranked version of your coding environment, packed into a prompt that is optimized for the model to understand what you are trying to build next. Now this packet travels, encrypted, fast, through a wire you never think about, to high-performance computing clusters running at a scale most developers cannot imagine. GitHub Copilot uses prompt caching and streaming protocols here to make sure network latency does not break your flow. The goal is that the data arrives before you even notice you were waiting. Inside the cloud, the real inference dance begins. A specialized language model, not just a generic one, parses your context window and begins predicting the most statistically probable continuation of your logic. These Copilot-specific models are tuned for architectural consistency, not just syntax correctness. They are trying to understand your intent, not just complete your sentence. And then the response begins its return flight. Token by token, your IDE receives the incoming stream and ghost writes the suggestion onto your screen before the full response has even finished generating. That is why suggestions appear to materialize as if someone is typing them in real time. But it does not end there. Before anything is finalized, post-processing filters scan the output for security vulnerabilities and offensive patterns. And the moment you press tab to accept or escape to reject, that decision becomes a data point that closes the loop on this entire cycle. So the next time Copilot finishes your function, remember, there was no magic. There was context packing, prompt optimization, encrypted transmission, cloud inference, streaming tokens, and a post-processing layer, all completing in the time it takes you to glance at your screen. That is not magic. That is engineering.